All right, we are going to look a little bit more specifically on even some better experiment designs, more specific experiment designs that will help control even more lurking variables. First of all, you need to know a couple things, a couple vocabulary words. The first one being a dropout. And that is someone who doesn't complete the experiment for any reason. And they may choose to drop out, or they may die, which is kind of sad, but that might happen in the middle of an experiment. But there's someone that, for whatever reason, does not complete the experiment. Then, a non-adherer is someone who participates in the experiment but doesn't follow the rules. So, like if they were told that they had to exercise 3 times a week, they maybe only exercise twice a week. If they were told that they needed to take their medicine, 2 hours after eating, and they didn't take it till 4 hours after eating, they would be a non-adherer. Okay? So, someone who participates but doesn't follow the rules. All right, we are going to look at some specific types of experiment designs. The first one being matched pairs. I'm going to fix this little thing right here. In a matched pair design, what you do is you find pairs of subjects that are similar in some characteristic that's relevant to the study. Like if I think men and women are going to react differently, then I'm going to pair a woman with a woman and a man with a man. Or if I think it's going to be different by cholesterol level, let's say, I would pair 2 people that have high cholesterol, 2 people that have medium cholesterol, 2 people that have whatever. And you keep finding pairs of people, lots of pairs of people, that you pair them up with some characteristics similar to each other. Okay? Then within those pairs, then you randomly assign which person gets which treatment. So you have to have at least 2 different treatments, okay? And then this helps control some lurking variables, because if you have subjects that are really similar to each other from the get-go and then you compare just their results, it eliminates some of those lurking variables as to whether your gender affects something or your cholesterol level affects something or whatever. But that is a matched pairs design. You can see a diagram that it would look like here. So you have a pair of subjects here, subject 1 and subject 2. In this case, I don't know what they were measuring, but it must be a pretest and a post-test. It might be in math or memory or something. I have no idea. It doesn't matter. But they were given a pretest, and then one of the subjects within each pairing was given one treatment, and the other was given another treatment, and then they were given a post-test to compare the results. So subject 1, you can see, and 2 are real similar to each other in some way. Subject 3 and 4 are real similar to each other in some way, and so are 5 and 6. So they're paired that way, and then within each pair, one gets the treatment and one gets the control. All right, then within subjects design is even more specific, and it's a type of matched pair, but it's where you use subjects as their own control. And each subject undergoes all treatments, and then you assess the effects independently. So basically, each subject goes through the experiment however many times their treatments are, however many treatments there are. So if there's 3 treatments, each subject would have to go through the experiment 3 times, okay? Sometimes you can have subjects go through the experiment at the same time. So for instance, here's an example. If I had, let's say I was testing a new lotion on hands, okay? I might have one lotion applied to someone's right hand and one lotion applied to someone's left hand, and they'd be going through the 2 treatments at the exact same time, but they're still being used on the same exact subject, and that subject is getting both treatments. Most of the time, they have to go through the experiment twice. Sometimes when it's things like that, that can be done to the left half of a body or right half of a body. You can do the experiment once and do something to one half and something to the other. But most of the time, they have to go through the experiment twice. Here's a diagram of that. In this case, I had 200 subjects, and I split them in half. And one group was randomly assigned to have yoga first, and then they were going to take a memory test. So they had yoga and they took a memory test and saw how they did. And then the next time they did the experiment, they jogged and had a memory test. And then I looked at, does exercise affect memory? What type of exercise affects your memory? The other group did it the opposite way around. So the other group jogged first, had a memory test, then had yoga, had a memory test. You want to make sure that even though everybody's going through all the treatments, you randomly assign people that get certain treatments first, and then another group of people would get the other treatment first, okay? And that's why they're split in half here. And you do that because maybe things like, I don't know, weather conditions or a major life event, worldly event happened that would have affected people's ability to memorize something or whatever. You want to make sure those things are controlled, and that's why you split which group gets which treatment first, okay? Even though they're going to both go through it, you're going to do it in different orders. All right, and then there's a block design. A block design a block is basically a group of subjects that are known to be similar in some sort of way to each other. So you might block by gender, you might block by no socioeconomic status, you might block by, you know, whether they've had a heart attack or not, whatever, but you're going to block by some variable. Okay, so you break them down by common characteristics first, and then you randomly assign subjects within those blocks, and again, this definitely helps control lurking variables. So in this case, I was looking at different creams to improve a rash, and so I took 300 subjects. 100 of them had very mild rash, 100 of them had a moderate skin rash, and 100 of them had a very severe skin rash. And I was looking at 3 different creams to see which cream would help benefit them the most. And so some of those 100 people got cream A, some got B, some got C within each group, and that's the way it goes, okay? Block designs are really, really common. And I should go back here, you guys, to the within subjects design and talk about this. Within subjects designs are pretty uncommon. You don't hear about them very often. And the reason is that they are very costly when you have to put subjects through experiments twice, and they take a lot of time. And oftentimes you can control the lurking variables well enough that you don't need to do a within subjects design and take all that time and money and put everybody or every subject through the experiment twice. So they're not real common, although they do control the very most lurking variables, because when you use treatments on the exact same subject, pretty much everything is the same about them. Diet's the same, exercise is the same, stress level's the same. You know, everything is the same about them except for whatever treatment that you are imposing on them. So it gives you great results, but it's oftentimes not worth the time and the money that it takes if you can control some other lurking variables pretty well. Okay, back to the block design. We talked about the cream. And so now we're going to just look at an example here that we're going to kind of diagram a bunch of different ways. So a researcher is investigating appetite control as a means of losing weight. And they found that female rats ate less and lost weight after injections of the hormone leptin, while male rats responded better to insulin. Okay, so first of all, we're going to design this study using a block design. And in this case, you can tell that probably you're going to have to block them by the gender of the rats, because that seems to make a difference in how they react to the 2 treatments that are being given. So if you do this in a block design, it would look something like this. You have rats. You're going to block them right here by whether they're male or female. That is not a treatment. That is a block, how you're dividing them up. And then half of the females are going to get leptin, and half of the females are going to get insulin. And then same thing with the males. Half of them are going to get leptin, and half of them are going to get insulin. And then what I'm going to look at in the end is their weight. I'm trying to control the weight of these rats. So that's what it would look like if it was block design. I would block them by gender in this case. Okay, if I was doing within subjects design, I would still need to account for the fact that I've got male and females. And so what I would do here is I would go like this. I would look at rats. I would still block them by male and female. Okay. Then you still need to split these. Half of the rats would get leptin first and then measure their weight. Okay. And then they would get So they'd get leptin for a period of time and then look at what happens with their weight. And then for a different period of time, I would give them insulin and look at what happens with their weight. Okay. The other half would do it just the other way around. They would get insulin first, look at what happens with their weight, and then they would get leptin next, look at what happens with their weight. Okay? And then the males, I'm not going to take the time to write it, but I think you can figure out that the males will do the same thing. Okay? And then if we were to do it in matched pairs design, what I would do is and you would have many pairs, but I'm going to just list a few pairs here. So you would have rats. that you would divide into, let's say, female pair 1. So I have a female pair right here, okay? So this is one pair, a female and a female, okay? And you would have many pairs of females, just so you know. But for the simple way to just write this all out, you would have, again, you would list many, many pairs of females. And then I would have a pair of males. And again, I would have many, many pairs of males. So I would put a female with a female, a male with a male, da 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 da. And then one of these rats would get leptin, and one of these rats would get insulin, and it would be randomly assigned who gets what. And then same thing with the men, or the male rats. I would get leptin, and I would get insulin, and I would be comparing this male to this male. And if you did it this way, you'd probably even be more specific, and you would put a female rat that weighs, you know, however many kilograms or pounds, probably whatever. However you would measure the weight of rats, they're not very big. But you would put probably 2 similarly weighted female rats paired up, and same thing with the male rats. So you'd be able to pair them up even more specifically than just by gender. But right now, all I know about is gender, so that's what happens. And then in the end, you are going to again look at their weight. Okay? And again, you would have many, many pairs listed here. I just listed 2 pairs, but you would have many, many pairs. And within each pair, one would get leptin, one would get insulin. Okay? All right, and that should do it for today.